My name is Matthew Richardson, and in this video I'll be talking about Faraday's law, magnetic flux, and at the end I'll be giving a good example. So, Faraday's law, a broad definition of it is the voltage accumulated around a closed circuit that is proportional to the time rate of change of the magnetic flux that is enclosed. So that's pretty much a broad definition of it. If you want to see the basics, it is pretty much the relationship between voltage and flux. It summarizes the way voltage can be generated. Okay, so I'll write out the formula right now and I'll show you it. Okay, so this is the EMF, or the voltage generated. It is seen as in volts. This N is the number of turns. B is the magnetic flux density. It is also seen as in Tesla. Sorry about that. Tesla. And Tesla is Webers per meter squared. A is area, and that is meter squared. T is seconds. Okay, so here's the equation, or the formula for Faraday's law, and yeah, there's much more complicated ones out there. It goes way into that, but this is like the most basic one. Let's talk about magnetic flux. That is the basic formula for magnetic flux, and it is B times A. You see right here? So this right here is magnetic flux. B is, once again, Webers per meter squared. Area, meter squared. These two will cross out. So magnetic flux is a Weber. A Weber is velocity times second. Okay, so that's pretty much all the That's pretty much all the terms and units in the equation. And if you want to see what magnetic flux is, so let's just use this as an example. Draw it out. So this circle represents the area, and all these little dots are the B's, or the magnetic flux densities. And so this little circle right here is what you see as a magnetic flux. And you'll see that in the generator or the motor when you have the magnets and armature. So you'll see the area. And it depends all on time and the number of turns. And yes. Oh, also, EMF. That is an electromotive force. Alright, so they'll see that between the brushes and the commutator. And so yeah, that is magnetic flux and pretty much Faraday's law right there. So let's talk about an example. Let me first draw it out and then I'll get to it. That's not good. Okay, so here we go. This is pretty much a permanent magnet motor. Sorry. Alright, so the magnetic flux density always goes north to south. This is just the way life is. It always works like that. So we got the current from the battery going to the brushes, going to the commutator, going up the armature, going down to the other brush, going down, going back into the battery. Alright, so here's the current, the voltage. We got the magnetic flux density going north to south. When you put the battery on, the armature, sorry I didn't tell you this, but this is the armature. And this is the commutator. And this commutator, brushes, armature. So when you put the battery on, it will throw electrical current through it, and then this will help it spin. This is the magnetic flux density, which will help it spin, because it'll put a force. In this case, let's just say up, and this side will be going down. Alright, So where the EMF is right here. Since when this is a motor, it'll be producing a back EMF. If you see a generator, it'll be producing just a regular EMF. And so yeah, that's Faraday's law. It is pretty basic, simple, and that's about it. Yeah, I hope you enjoy the video, and thank you.